All right, so today we are trying to derive an equation for the mass of an above ground storage tank. We want to use the things like surface area, volume, and density, and we want to break it down into the smallest variables that we can. So basically from here, if we're looking at just a storage tank, it's just this top half. Okay, so we're going to have diameter D, height H, density of the steel, and shell thickness T. So we want it to derive in terms of the height, okay, the diameter, the density, and the thickness. So those are our givens that we have, okay? And then the unknown is the mass. So we know we have this equation that says density is mass per unit volume, mass over volume. We want to solve for mass, so we're going to rewrite this to say that mass is equal to density times volume. So that's our equation that we're really solving, but we have to put it in terms of these. Well, it's already in terms of density, so that's easy, but we got a volume we don't have. So height, diameter, and thickness instead of volume. But it's kind of like length, width, and height, right? So that all works out. So mass is equal to density, okay, times this volume. But let's look at the volume. So let's look at my storage tank. So we're just doing the storage tank. Okay, so that's what the storage tank looks like, but we're going to break it into three parts. We're going to break it into the top. We've got the bottom. And then we've got these sides, this curved side that goes all the way around. If I look at the sides, if I look at the top view of the sides, it's this little tiny skinny, and I can't draw it as skinny as it really is, but it's really just this. And what I'm going to do is I'm going to cut that in this spot, and I'm going to flatten it out. When I flatten it out, it's going to make this big, long, flat piece like this that's got this thickness to it, right? And it's hard to draw that little skinny thickness. This is the sides. The top and the bottom both look exactly the same, right? The top and the bottom are just these skinny little discs that they sit because the middle is empty. That's where all the fluid, the petrochemical, is going to go. So this is the top and the bottom. And they're exactly the same. So when we're doing this, we're going to take that density, but we got to have the volume of the sides plus the volume of the top and the bottom. So it's the volume of the sides plus these two things, but they're exactly the same. So we're just going to say 2 times the volume of, we'll call it the top bottom, TB. Okay? But still, we've kind of broken it down a little bit. We still haven't solved these in terms of these letters other than density. We still got an H, D, and T in there instead of volume. So let's look at these, and I'll do different colors. So we're going to do the velocity of the sides in pink. Okay, so the velocity, the volume, sorry, the silly dad. Where am I today? Silly teacher. I'm a dad, but not yours, obviously. Okay, so velocity of the sides is equal to, now if we think of velocity, I keep saying velocity, volume, wow, volume of the sides is equal to, on this thing here, it's kind of like we have a length, right? We have a width, and then we have this depth or height, whatever we want to call it, this part going up and down. Okay, so it's kind of like length times width times height. That's the volume, if I can say that right, of this part. Well, we don't have L, W, and H. We've got H, D, and T. So let's look at the length. What was the length? We took this thing, and the length was this stuff all the way around the outside. So the length is equal to the circumference. So L is equal to circumference. Well, circumference of a circle is equal to 2 times pi times r. So we're going to replace that. This is going to be 2 pi r. The width is this width here, but that's this, right? What was that? That's the height. Okay, so that's the h. And then this height that we counted, the height here, because we're sitting on our side, okay, this height is actually the thickness of the thing, and if we look back, the thickness was the t. Well, that's great. Look, we've got H and T, but we have R instead of D. But D was diameter, right? If we look back at our chart, D was diameter. So R is equal to diameter divided by 2, isn't it? So we're going to replace and say we're going to have 2 times pi times d over 2 times h times t. Well, if we multiply by 2 and divide by 2, it's just a waste of our time. 2 over 2 is just 1. So we can say the volume of the sides is equal to pi d h t. There we go. That part's done. We can replace it, and we'll do that in a minute. Okay, now we're going to do the volume of the top and the bottom. We call that volume TB. Okay, so this one, when we're doing a cylinder or a disc, we really don't have length and width, right? Because it's a circle. So it's not like a rectangle like this. So instead of this length and width, we really just have the area of a circle up here. So the area of the circle is equal to pi r squared, right? And again, I told you this all day. It's my best joke. Pi aren't square, cake are square. Pi r round. But anyway, pi r squared is my area. And really what we're doing here to find the volume, it's just the area of the circle times the thickness of the circle, or the height of the circle. But we know we're going to put it in terms of thickness because that's what we've been talking about. So we might as well call it thickness. So this is just pi r squared times the thickness. Well, what was the thickness? It was just t. Okay, because the thickness of this disc is the thickness of that. It's all the same steel that we're using. But again, we're not in terms of r, we're in terms of d. But r was equal to d over 2. We already wrote this down up here. So we're going to replace that and say pi times d over 2 squared times t, which is equal to pi. D times d is just d squared. 2 times 2 is 4 over t. So that's the volume of the top bottom. But what did we want? We wanted 2 times the volume of the top bottom. So 2 times the volume of the top bottom, right? Because we just found volume of the top, but we want both, so we have to put the 2 in front, is equal to 2 times pi times d squared over t, and all that's over this 4. Well, 2 over 4 is just 1/2, so that's equal to pi d squared t all over 2. And now we have this, which is going to go here. We have this, which is going to go here. So let's rewrite our equation to finish it up and say that mass is equal to the density times the volume of the sides, which was pi d h t, plus, right, plus 2v, 2 times the volume of top bottom, which is just this, which is pi d squared times t over 2. Oh, helps if I move it up so you can see it. And we can leave it like that and we're done. Or we can simplify and move some things around. So you could say mass is equal to density. Look, there's a pi in both, so we could pull him out. There's a d in both. If you want to pull that out, you could. Okay, there's an h not in both. There's a t in both. We could pull that out. Okay, so let's go through. So this one, we took the pi away, we took the d away, we took the t away, so all we have is h. Okay, and then we're going to add it to, we took the pi away, we took one d away, so we still got a d. We took the t away, and we have the 2. So either one of these works. Here's a simplified version. They both work. This one's probably easier to put in your calculator, but that, you could have stopped anywhere in between. It's all good because you notice we have mass in terms of those 4 letters we were looking for. All right, let me zoom out so you can see the whole problem at one time. We have mass in terms of density, in terms of pi, which is just a number, in terms of diameter, in terms of thickness, and in terms of height. And then there's just diameter again. And if we look back at all of our, no matter which group you got put in, every one of them has diameter, height, density, and shell thickness. So now we could solve if we wanted to. And that is all there is to it.